Morning everyone, my name is David. Today we are going to talk about the hydrogen used in automotive industry, especially in heavy truck. Canada's heavy truck fleet consists of 1.1 million trucks and about 90,000 buses. Approximately 48% of these trucks have a gross vehicle weight rating of 15 tons or higher, most of which are likely to be involved in fleet services. The remaining 52% of heavy truck fleet consists of goods vehicles and occupational vehicles, such as garbage trucks, construction vehicles, and government service vehicles, with a gross vehicle weight rating of 4.5 to 15 tons. These heavy-duty vehicles are primarily diesel-fueled and emit approximately 9% carbon dioxide per year, which is 65 metric tons per year. Thus, total greenhouse gas emissions in Canada are expected to increase as population and economy grow, along with the demand of these vehicles and fuel consumption and emissions, in order to meet Canada's net zero climate change goal. While addressing air pollution emission and ensuring vehicle performance, electrification of the powertrain is a necessary step into the future. Hydrogen energy as a source of green renewable electricity has a significant impact of vehicle emissions, especially those from heavy diesel trucks. By reducing greenhouse gas emission by 80 to 100% over the life cycle, it can provide a reliable transition to a net zero emission in the future. Currently, many companies have been investigating and researching hydrogen fuel cell technology around the world.
When it comes to the amount of hydrogen vehicle used, hydrogen vehicles are only taking up a small percentage of the vehicle around the world. Based on the research, there were 6,500 hydrogen fuel cell vehicles in 2018, which is much less than the 1.1 billion internal combustion engine vehicle in 2015. Obviously, there are some advantages to hydrogen vehicle. First, it reduces the greenhouse gases since the production of burning hydrogen is water only. Second, the hydrogen vehicle can be fast refueling. The hydrogen refueling will take up 3 to 5 minutes in the refueling process, which is different from the long-time charging for an electrical vehicle. Additionally, the hydrogen vehicle has long traveling range. A full tank of hydrogen can support the vehicle traveling around 500 km, which is close to the classic vehicle nowadays. Lastly, the hydrogen has higher engine efficiency. The hydrogen fuel cell vehicle has an engine efficiency of 65% compared to the internal combustion engine of 35%. However, there are some disadvantages that exist on the hydrogen vehicle. First, less infrastructure constrains the development of the hydrogen vehicle. Based on the research, there are only 39 hydrogen charging stations in the United States, for example. Apart from that, the high cost of the vehicle itself also constrains the development of the hydrogen vehicle. Finally, from the perspective of the safety consideration, the people worried about the dangers of the hydrogen technology. Since the cost of hydrogen vehicle is relatively higher for an individual, so one of the implemental solutions is encouraging the public hydrogen vehicle like hydrogen bus and taxi or a hydrogen sharing system. By doing this, it makes more people enjoy the convenience of a hydrogen transportation system and save their costs on buying an individual hydrogen vehicle. So even though there are still many doubtful judgments for the hydrogen vehicle, the transition from the fossil fuel energy to sustainable energy will never stop, because it will be the mainstream in the future.
Diesel heavy-duty trucks are a mature technology on the market today, and the capital cost of Class 8 freight tractors is about 165,000 Canadian dollars. Since the fuel cell heavy-duty trucks have not reached commercial scale yet, the cost of access remains a wide unknown. According to the data, hydrogen fuel cell trucks are expected to cost 2 or 3 times as much as diesel trucks, which could range from 335,000 to 455,000 Canadian dollars. However, as the cost of components falls, the technology is developing rapidly, and these prices could be even lower in the future. Fuel cell system is one of the most expensive components, which is about 73% of the cost of energy module. Hydrogen tanks is about 15%. At 2030, the cost of fuel cell can be reduced by 70% to 80%. the cost of hydrogen will reduce 85%. But this cost reduction based on the fuel cell truck production capacity of around 150,000 units. And one potential huge maintenance cost factor is fuel cell and battery replacement. Life expectancy is 25,000 hours. A 308 kilowatts fuel cell costs 190 Canadian dollars per kilowatt to replace. But these numbers will fall as fuel cell technology development. Similarly, batteries current cost about 200 Canadian dollars per kilowatt hours to replace. And another one is energy cost. The cost of hydrogen depends on how it is produced, distributed, and prepared for consumption through purification, storage, and compression. Moreover, the price of hydrogen will fluctuate with the price of raw material and the price of electricity for green hydrogen or the price of natural gas of blue hydrogen. In addition, expect the hydrogen production cost. A significant portion of hydrogen transportation cost is due to distribution. This includes transporting gas through pipelines or trucks. CSIR estimates the price of hydrogen at between 3.5 to 5 Canadian dollars per kilogram, and the wholesale price of diesel is 0.75 Canadian dollars per liter. But since hydrogen is about 3 times the mass of diesel and gasoline and is far more efficient than them, it is more cost effective. Due to the low price of natural gas in Canada, the wholesale price of hydrogen produced using SMR technology in combination with CCS is expected to be less than 1.5 Canadian dollars per kilogram if produced on a large scale. However, without a large-scale hydrogen distribution system, the retail price of blue hydrogen could increase by 4 Canadian dollars. However, with the future electrolytic cell technology decrease in cost and combined with the cheaper renewable energy sources, some researchers believe that the green hydrogen could compete with the diesel as early as 2030.
Nowadays, the long-distance haul tractor and trailer entirely depends on the diesel engine. Determine whether the hydrogen fuel cell truck could replace the diesel truck in future. A comparison must be made between those two kinds of tractors. The diesel engine is the most mature and common power resource now. However, it consumes a large amount of fossil energy and highly emits polluting gas including carbon dioxide, carbon monoxide, and NOx. On top of this, the diesel engine's efficiency is also very low, which is about 35%. Combined with transmission and drive shaft, the total efficiency will even lower. Consider those disadvantages of diesel engine. The hydrogen fuel cell stack and electric motors seems to be the best solution. First, the efficiency. The efficiency of a hydrogen fuel cell is about 80%, and the electric motor efficiency is 90%. So the total efficiency is 72%, which is significantly higher than a diesel engine. Second, the emission of hydrogen fuel cell is only water, so it is much more eco-friendly than diesel and emits no greenhouse gas. However, there are also some problems to solve in order to take the place of diesel engine. First, the hydrogen fuel cell tractor is heavier than the diesel tractor. The diesel tractor's powertrain structure consists of a large diesel engine, transmission, and fuel tank, which is 2,876 pounds, 800 pounds, and 560 pounds, respectively. The total weight added to the cabin and chassis is 4,236 pounds. However, the hydrogen fuel cell tractor's powertrain system comprises an electric motor fuel cell stacks and fuel tanks, which is 4,500 pounds, 4,400 pounds, and 100 pounds, respectively. The total weight is 9,000 pounds on top of the cabin and chassis. Consider the total tractor weight. The hydrogen fuel cell tractor is 40% heavier than the diesel tractor. As a result, the hydrogen fuel cell tractor needs 28% more engine power and carries 4,764 pounds less load in the trailer. Second, the fuel cell tractor carries less weight of fuel, which is less energy. Due to the limited of hydrogen tank technology, the hydrogen tank can carry only 187.39 pound hydrogen, which stores 9.66 million BTU. However, the diesel truck can carry 730 pound diesel, which is 11.5 million BTU. Third, the cost of hydrogen fuel cell stack is much more than a diesel engine and transmission.
Hydrogen is approximately 3 times higher than gasoline in energy density by mass. However, hydrogen is almost 4 times lower than gasoline in energy density by volume, from passenger vehicles to heavy-duty trucks. Hydrogen is not volumetrically efficient. There are two current physical-based solutions, which are compressed hydrogen gas and liquid hydrogen. Both methods require a high-pressure vessel, 350 or 700 bars. There is one more future material-based solution. By using metal hydride, it might potentially overcome the limitation of physical-based storage. There are three main vessel materials. The carbon fiber has the best performance but also costs the most. The glass and aramid fiber are way cheaper. However, they cannot perform as well as carbon fiber. The figure here shows the potential locations of the storage tank on the medium and heavy-duty trucks or buses. Here also shows another disadvantage for hydrogen storage tank. The pressurized storage tank does not like gasoline tanks, which can easily conform with other vehicle components. Throughout the assumptions, analysis, and calculations, the approximate solution in storage tank size for medium and heavy-duty trucks is 50 and 85 kg of hydrogen at 350 and 700 bars. Moreover, in order to estimate the hydrogen storage sizing more accurately, having approximate value of the amount of storage hydrogen, mass of storage tank, gravimetric capacity, volumetric capacity, L/D ratio, and the effect of storage pressure all provides a useful starting point when considering how to design a particular fuel cell electrical truck.
To sum up everything that has been studied so far, hydrogen as the largest storage of green renewable energy on Earth, which can improve the quality of human life and effectively protect the environment. But even hydrogen fuel cell technology is more efficient than diesel or gasoline. Both the technology and manufacturing of hydrogen fuel cells, the storage of hydrogen energy is extremely expensive. As a result, hydrogen fuel cell technology is not yet fully competitive with diesel and gasoline. But as technology continues development, hydrogen fuel cell technology could become part of Canada's zero-emission approach, which also in line with emerging innovations that are reshaping the industry, such as autonomous driving and physical internet logistics, as well as the good fit for many not fit in battery-powered electric drivetrain systems, such as long-distance trucking. In addition, hydrogen fuel cell technology could be starting point for a transition to a hydrogen economy with huge economic, environmental, and energy benefits. Therefore, it will take some time for the popularization of hydrogen fuel cell technology to fully enter our vision. And countries around the world should also make good preparation for development of hydrogen energy technology and provide them with a system they need. Thank you for listening.